Alright, hey everybody. So we are now on our next video. This is 3.7 and it is all about succession. So we'll see how disturbances can impact our ecosystems. So first we'll start off with this example. So in 1883, the volcanic island of Krakatoa in the Indian Ocean was blown to pieces by an eruption. The tiny island that remained was completely barren. However, within 2 years, the grasses were growing. 14 years later, there were 49 plant species, along with lizards, bats, and insects. In 1929, a forest containing 300 plant species had grown. Today, the island is covered by mature rainforest. So how the heck did this ecosystem recover from such a catastrophic event, this volcanic eruption that blew it to pieces? How did it recover from that? And we'll look at how an ecosystem is able to do that. So the first thing we want to look at is that these disturbances to an ecosystem happen fairly often. So the ability for the ecosystem to then kind of bounce back from these disturbances is really important, and understanding that is very important, how it's able to do that. So first off, we want to look at what is a disturbance. So a disturbance is something that typically will strip away the vegetation, and sometimes if the disturbance is so great, it'll actually even take away large amounts of the soil. And we'll look at kind of the difference between those two and how long, if you just take away the vegetation, it'll maybe be a little bit shorter for the recovery time versus taking away the soil, it might be a little bit longer. So ecological succession is really analyzing how the environment has been disturbed by something. What are the predictions? How can we look at how it will change, and what predictions can we make about these changes? So we're looking about these predictable changes that will occur in this community over time, and really how it's going to recover. What species are going to colonize this area that was disturbed, and are those species that originally colonized it, will they be replaced by other species? So we will look for these changes that are going to happen to this environment, to these different ecosystems. So there are two major types of succession. First one we'll talk about is our primary succession. So this is actually when we have an ecosystem that is completely barren. There is no life there at all. All it has is rock. There's only rock left behind. So the first example that we looked at with the volcanic eruption, basically because of that eruption, it got rid of all the vegetation and it got rid of all the soil that was present. So this is an area that is virtually lifeless and it has no soil. Those are the defining factors or characteristics of an environment that is going to undergo primary succession. No soil is there and there's only rock. So two major ways that this happens is, one is the volcanic eruption, or another option, or another thing that could happen is a retreating glacier. So sometimes glaciers will come across land masses, and because they're ginormous, they're huge, they will take with it, the vegetation, but it will also take with it the soil. And by doing that, getting rid of the soil depends on the ecosystem, but it could take a very long time for this ecosystem to reach its climax community. And we'll talk about what we mean by that in a moment, but it could take thousands of years to recover from a situation like a volcanic eruption or retreating glaciers. Depends, but it could take a very long time. Versus secondary succession, this is when there is a disturbance that will affect the vegetation and typically the biotic factors that are there, but it leaves the soil alone. It's intact, it's there, and it's available. So examples of something that could cause or kind of start this process of secondary succession are wildfires, which will burn the forest, but we still have the soil is still there. Hurricanes can also be another type of natural disaster that could result. Tsunamis could also be another one. But as long as the soil is still there, secondary succession will happen. And in order to reach our climax community, it usually takes a lot less time. So this one could take maybe 100 years or even less, but to reach the climax community. So primary succession typically takes a long time to reach that climax community, but secondary succession might not take as long. And really quick, what is a climax community? Well, this is the type of ecosystem, or the kind of like the more stable stage of our community. So it's a little bit more resistant to changes, but it still can change. Even though we call it like the stable community, it still has the potential to change if some crazy thing happens, like a volcanic eruption happens, or a glacier comes through, or there's a huge hurricane, forest fire, right? That can definitely change our climax community. But another thing to recognize is that for our different ecosystems, there will be different climax communities. So like a forest, what we expect to see for a climax community are lots of very big trees around, right? But then for a desert, very different climax community. We don't see big trees here. And then a grassland, you're not going to see big trees in this one, but as long as it has those characteristics that make up that community, then it has reached its climax community. Same with the coral reef, looks very different than our other communities. So climax community is different for each of the ecosystems. Here we'll look at what is the first thing. So if primary succession happens, volcanic eruption happens, there's a retreating glacier, it strips it away with all the soil, then how can anything grow if there's no soil? We call the first organism that will colonize the area after this primary succession, we call it the pioneer species. And so a really good example of a pioneer species actually is lichen, because lichen can live on the rocks and it will break them down and they can survive that way. And by breaking down the rocks, it eventually leads to soil production. Even as the lichen dies, it contributes some nutrients to the soil. So that's our pioneer species. Typically, we'll see lichen as one of our first species that will inhabit an area where primary succession is occurring. And so here's, I think, a nice visual of what's going on to compare primary succession versus secondary succession. So once again, primary succession is always defined by the soil being stripped away. And so we have rocks that are available here. Eventually we have rocks with moss, or maybe lichen is developing, right? And then we get to our grasses, then we get to our shrubs, then we get to small trees, and then we get to our big trees. So it's a progression of how it is changing over time, as opposed to our secondary succession, which is still a progression over time, but we have our soil left behind, and so it's a little bit of a quicker process to get to our final, but get to our kind of our end, our climax community, and we can kind of see that progression here as time goes on. And just another thing here, another example, and I have this question, you know, is this an example of primary succession or is this secondary succession? And yeah, this is an example of secondary succession because soil is here. We have actually some plants that are left behind, and then we see this progression over time to eventually we get to our more hardy plants. But you do want to recognize that at first we had these small grasses that were present in this environment, but then it is replaced by these bushes and these small trees, and then eventually replaced by these very large trees. So even though these initially maybe started this off, these will kind of result in our climax community and will be there at the end. All right? Yep, so that's the end of this information about our succession. So I hope it was helpful, and if you have questions, please let me know. Have a great day. Bye.